The most important thing to remember when we are solving linear equations is that we are isolating the variable on one side of the equation. So in these first couple of examples, we only have one occurrence of the variable, so we'll go ahead and isolate that. First, we will subtract 5 from both sides so that we get negative 6x equals 12. And then dividing by negative 6, we arrive at our solution, x equals negative 2. Now I would suggest occasionally, I'll go ahead and do that here, checking your solutions. That's our proposed solution. So hopefully this statement is true. Well, this would be 12 plus 5, which is in fact 17. Therefore, x equals negative 2 is our solution. Occasionally you'll want to check that. There are some equation types that you have to do that. In our second example, we will add 4 to both sides to arrive at negative 7a equals 14. Dividing by negative 7, we see that a equals negative 2. And again, we could go ahead and check that. I'm going to do that mentally. I'm going to go negative 2 times negative 7 would be 14 minus 4, which is in fact 10. So a equals negative 2 is our solution. Moving on, we have something else. We have 2 occurrences of our variables. In fact, on the second equation, we have 3 of them. First thing we're going to do is simplify both sides of the equation when it gets more complicated. Simplify both sides, distributing, combining like terms, and then you will move one of those variable expressions to the other side, arriving at something that looks like the last question type. So for this one, I don't have to simplify anything, but I am going to subtract 5x, and the side that you move is irrelevant. I could move it to the right or the left. I'm going to go ahead and do the left, so that's negative 2x plus 2 equals minus 8. Now it looks just like the last type we were looking at, so we'll subtract 2. So we have negative 2x equals negative 10. And then dividing by negative 2, we see that x equals positive 5. All right, our next equation, again, we'll simplify. So we need to distribute the 4 so that this is 4k minus 12 minus k equals k minus 6. We haven't simplified the left side completely yet, so we'll combine these two k terms to be 3k minus 12 equals k minus 6. Doing like in the last question, we will subtract k from both sides so that we have 2k minus 12 equals minus 6. Adding 12 to both sides, we have 2k equals positive 6, and then dividing by 2, we find that k equals 3. Now, the more complicated the equation gets, the more important that it is that we go back and check. So while I'm not doing that here, I very much suggest that you do that to guarantee not only that I'm doing this correctly, but that when you're doing this independently, that your answers are correct. All right, 2 more like that last one. I'm going to move again my variables to the left side, so I need to, rather than subtract 4, I'm going to add 4x so that I have 8x plus 5 equals positive 29. Subtracting 5. And I hope these examples are useful to you. It's 24 dividing by 8. I see that x equals 3. All right, my last equation that we're going to work. I need to distribute, actually on both sides, because I need to simplify both of these. So on the left side, that is 3x minus 6. And on the right side, that's minus 2x minus 8. Negative times a positive is negative. Now I'm going to move my variable terms to the left, so I'm going to add 2x. That would be 5x minus 6 equals minus 8. Now we can add 6 to both sides. 5x equals, that'd be minus 2. Dividing by 5, I have that x equals negative 2/5. There's our solution. Now, it is, again, of utmost importance that you can always check these by plugging them back in. Again, later in some other sections, we are going to have to do that every time.